All right, we are going to talk about how to use the sine rule and the cosine rule in some practical applications. This is lesson 9.8, so let's get started. I need to know what to use and when. So let's summarize what we talked about for cosine rule and sine rule. If I have the three sides but no angles, then I'll use the cosine rule. If I have two sides and the included angle, I will also use the cosine rule, but those are the only two instances. If I have two sides and the non-included angle, then I will use sine rule. If I have two angles and an included side, I will use the sine rule. And if I have two angles and a non-included side, I will also use the sine rule. So use the sine rule on those last three. I think the only other thing that can happen is that you only have the angles and none of the sides. Well, that's not enough information to tell me anything about the triangle because I need at least one side length to know how big it is. Okay, so remember an old example. This was the one about the flagpole, and we talked about Jack. He stands, he's looking up, and then he walks 8 feet away. He looks up again, and he's looking up at an angle of 60 degrees. The second time I filled in that x, I wanted to know what the height was. Well, I had to use old trigonometry to do that where I could only use right triangles. Well, now that I have the sine law or sine rule and cosine rule, I don't need a right triangle to figure out the lengths. So what I did was I took that triangle that's on the left, that obtuse triangle, and I figured out the two missing angles. I figured out the 110 being supplementary to that 70-degree angle that's sitting right there, and then the 10-degree angle because I had the other two angles, the 110 and the 60, and I only need 10 more degrees to make a total of 180. So that's how I got those two angles to figure the angles in the diagram. I want to figure out the length of that purple line because if I can do that, then I can figure out the height of the flagpole. Okay, so I have two angles and a side in the left triangle. I can pick any two angles that I want, but either way I have to use the sine rule. So I will say that 8, which is the bottom side, over the sine of 10, which is the angle opposite, equals y, that purple side, over the sine of 60, the angle that's opposite the y. Okay, so that's how I set it up. The side and the angle that are opposite each other always appear in the same fraction, in case you hadn't made that discovery yourself. So now I cross multiply, I solve for y, and I get that y is equal to 39.8979. Now I can turn my attention over to this plain old right triangle that's sitting here before, or that's always been sitting there since before, and I can use trigonometry to solve it. I know that the hypotenuse is 39.9. I want to know the opposite, which we called h. So I say that the sine of 70 is h over 39.9, opposite over hypotenuse, just like always. And so the height is 37.5 feet. So that's the same answer that I got before. It was just a little easier this time. Here's a simpler example that I'm going to go through with you. I want to know what the area of this triangle is. And all I know is that the sides are 12, 13, and 8. It's not a right triangle. I don't have the height, so I can't use the old formula. And I don't have any of the angles, so I can't use the new formula. So what I'm going to do is I'm going to use the cosine rule to figure out one of the angles, and then I can use the new area formula. Okay? So I'm going to find the measure of some angle. I'm going to call it C. The two sides that touch it I'm going to call A and B, and then I can use the area formula that I discovered in this unit, which was 1/2 times side A times side B times the sine of angle C. So the first thing I'm going to do is find the measure of any angle, and I'm just going to pick that one right there. The sides that touch it are the 12 and the 13. So I'm going to call it C, angle C. So I'm going to use the version of the cosine rule that has angle C in it. And that's c squared equals a squared plus b squared minus 2ab cosine c. Substitute in what I know. C becomes 8, a becomes 12, b becomes 13. And so all I need to do is figure out angle C. I square those numbers and do the multiplication that's necessary. Subtract things over to the left-hand side and divide by that negative 312, and I get the cosine of angle C is 0.798. I need to know an angle, so I need to use an inverse. So C will equal the inverse cosine of 0.798, and that ends up being 37.1. So that's that angle right there. I've labeled it A and B. Remember, I need to name A and B so that they are the sides that touch that 37.1 degree angle. Well, 8 is on the complete opposite side, so that's not it. The two sides are the 12 and the 13. So randomly, it really doesn't matter. I'm going to say that A is 12 and B is 13. And so lastly, using that information, side A is 12, side B is 13, and angle C is 37.1, I'm going to use that formula, plugging in A is 12, B is 13, and C is 37.1, and I get that the area is 47 square meters. So that's kind of a simpler example without multiple triangles in it, where I would use the sine rule and or the cosine rule. If you have any questions, please let me know, and I will see you tomorrow.